So we go ahead with the last presentation today. It's a little bit of summarizing, having a look, success stories, where have FDT been used, a little bit also focused on South Africa, because we have here also some of these applications. But first of all, I would like to give you some nice application, especially with positioners, with Arkema. Arkema is a company coming out from the Total company in France, especially. They had a reorganization 2004, and this company activities, they have three folds: winning products, industrial chemical, and performance products. And this was a company which is really big. I think it's involved in 40 countries with 17,000 people involved in that. So it's a pretty big company, and we have now a concentration on this Lannesemaison plant in France, in the south part of France. There was at least the subject, their production, a chemical plant, especially, let's say, a hydrate, I don't know, a special product, which is explosion-proof, very critical, what intrinsic safety concerns. And here in this plant, there were a lot of improvements which were needed. They wanted to have more diagnostic, they wanted to drive more careful on the plant, but we will see what they at least did. They are producing 47 tons a day of this very special product. Well, the point, the challenge of this customer was, because of this old instrumentation, to change from the classical 4 to 20 milliamps to more communication. Yeah, they tried to have access to the hard communication protocol. There were already hard devices installed in the plant, and now they wanted to have more information from the device. Yeah, because before it was a little bit poor, by only having 4 to 20 milliamps, and now a step further. Then, of course, they wanted to avoid having multiplicity of manufacturer-specific configuration. Means they had a lot of different tools. Yeah, they had different tools for the different companies involved in this project, and then they wanted to change to one standard new tool, yeah, one standard possibility. And due to that they had intrinsic safety areas, zones, explosive zones, they wanted also to avoid that the persons go out to the field. Yeah, they wanted to have some central place where they configure and have their diagnostics possibilities. So avoiding human persons having out in this dangerous zone. And last but not least, of course, optimize certain control loops. You must imagine there were really critical loops where they have to have a little bit more view on that. Yeah, there are some. I have two examples where they really take care and have continuous information using diagnostic information. So customer challenge, of course, to create a common instrument database, because before they had a lot of different databases on different programs. And now have a look who was involved. For example, Mettler Toledo with pH meters. Then we had Foxborough, or especially Eckert, with the positioners mainly. And Foxborough then with pressure and flow meters. Then Rosemount also with pressure and flow meters involved. Yokogawa, pressure meters. Vega with level. And Samsung, also Samsung, further positioners. You see, it is a very big mixer of different companies using different instruments. And the big challenge was to put all on one database, on one program, using, for example, FDT. And well, of course, for all these companies, DTMs were required, but it is not a big deal. We had mostly for most of them, we had this DTMs. I think for Siemens they use these so-called generic DTMs, because in these times they don't have own DTMs for these devices. But this was a challenge to put all on the same database by used in the same program. And here you see a little bit of structure, only symbolic. I don't want to explain anything in that, but important is really here the new, let's say, remote IOs. Put it in the field at least, and these remote IOs were able to use hard devices. That means hard transparency, and with the DTM you can connect to these hard devices. This was the mainly change, so that really all the devices could offer their hard information, could offer their intelligence. Yeah? So they had to build here a new infrastructure. Could let that above as it was, but at the bottom was the mainly point. And then solution, well, installation of FDT. They choose the tool Pactware. For them, the argumentation Pactware is a free tool. It is a configuration tool and does the diagnostic which we want was enough. So they choose for this tool. And well, DTMs like from Foxborough, from Samsung or from Vega were included in this program so that they have access to these devices. Okay, hard communication is given by the I/O cards. We saw it before, these I/O cards from Invensys at least, and so that we had then access top-down to the devices. And here there are some pictures regarding that. For example, they had now from a central place the possibility to work with the positioner, to have a look on the positioner. What is the status of the positioner? And here important, for example, is to see the difference between the actual valve position and maybe the required set point. Yeah, you see here in this area if they are working on a false area or on a good area. And so they could determine in previous, before something fails, they could determine, oh, our valve is running away from the optimal point of setting. Yeah? So they had continuously possibilities to check the positioner and the valve and had this information online, yeah, via diagnostics possibilities. So big advantage, of course, they could really react before the valve falls. Yeah? They could see, okay, something is wrong, maybe mechanical parts, something is running not so optimal like before. They go out, they could plan their service, really planning. You must imagine before they make regular service plans. Yeah? Every half year or so, go out to the valve number 15, check. Yeah? And this regular testing or this regular checking for some devices were now completely changed by a reaction of the valve itself. So you really were, let's say, triggered to go there, and not by very expensive, continuously every half year go to the valve. So this is a big performance, and of course the DTM itself could give alerts if let's say if there is an abnormal deviation, there were some alarms activated. It is all coming out from the DTM. You can program it. You can say, okay, my valve is here in the optimum, and then if I go in this direction or in this direction, I can put some alarms, and I were activated. Yeah, I can start making these things. This was big improvement because before they don't had these possibilities by making this, let's say, diagnostic and asset management online. Here, two critical valves. There were two valves which were defined as critical because you see there are general steam supply valve and column level control valve. Yeah? These were two valves which were really difficult to handle, where you really had to check continuously. And here the solution was also this for a continuous monitoring of the friction. Yeah, that means due to that they had really this program in a unique way. They could continuously have a look on the valve and check it every minute or whatever. So this were checked also by this program automatically with a higher priority, of course, yeah, than other ones. Because, well, critical stories is always dangerous, and in this part, the program or this database, this unique database, gives a lot of help and the assistance with asset management functionality. Some results here also. Well, due to the different DTMs from all these suppliers, and the customer get almost all DTMs, and for those who didn't, the DTMs were not available, they used the generic DTMs, there were a big improvement in the plant. Yeah? Imagine from having no information and making everything very static, going out and back again and checking by some time schedule, to an event-controlled check. Yeah? That means guided by the by assets and guided by diagnostic information, it's a big change, a big challenge, and this was a big improvement at the end. Yeah, and some of the loops were optimized thanks to the diagnostic incorporation instruments, especially these critical ones, yeah, where we say these hot loops in this case. Well, and of course, also a big thing was that the personnel didn't have to go so often now in the field. Yeah? Everything could be done, or the most of the things could be done from your control room or office area, and personnels don't had to go so often down in this intrinsically safe hazardous area and going with laptops, and then they had to make special permissions to go out, and all these things disappeared because now the mainly things were done from the office area or for the control room. Yeah? It was a big benefit. Well, here again, a little bit summarizing the benefits. FDT DTM, a common interface for all manufacturers. That means one tool, not 10 or 12 as they had before, one tool for all manufacturers. Then, of course, having this predictive maintenance or predicted health. That means the positioner were asking for help. Hey, I'm running out of my optimal position, yes? Please help. And this predictive maintenance leads to a better planning of service for these guys, yeah? And reduction, of course, of the maintenance cost. Due to this, all interventions are optimized and quicker. Yeah? You could really react on the possible faults which could appear. And at least no more need of software updates on laptop computers. You were all centralized on one point. From there you had your main database, and from there you had your control to all your devices. And it was not more needed anymore to have different programs in different computers, and everyone is running with one program of one manufacturer. So everything centralized on one place. And this Mr. Nones from this company, Argema, says, okay, since converting the instrumentation in this product here, Hydrocene workshop to digital, yes, conversion to digital, and installing and using Pactware, we have been able to carry out our various downtime jobs within the allowed deadlines. Yeah, so they gain a lot of possibilities in this case. Good, here are some further pictures, like what were presented. You see here the DTM giving you a list and giving you also a list with colors. Means in this case here, everything is okay. Here you see a yellow warning information. That means the device is working out of specification maybe. Maybe it's too hot, or maybe something is wrong. So here you have to be careful. Maybe you have to plan a service to this device. And here on this button, you see a clear, okay, I'm faulty, something is wrong, but you see it in your computer relatively early, and you can react on that. Yeah, that was the mainly point, so that you can react on that. Here again, you see here in the background also some information on diagnostic measurement values. You can also see the values itself and have here some further information of the device. This using the communication to the device, which was before not available. Yeah. Well, Arkema is a company who also delivered some product, or this special product, to Sasol. Yeah, that means this comes to Sasol. They are using this hydrazine, and well, it's a story which I want to follow up, and so I come now to South Africa and maybe things which we have already done here. Sasol, for example, of course, they are using different. It's a big plant, and they are using hard devices and Profibus devices, networks. It is very, very large plant, so you have really to think about how to connect to the devices. Do you want to go to the devices, or maybe make it that via network structures? Yeah? And due to this large plant structures, it is sometimes very interesting to do that via networks. And well, device accessibility, calibration made easy with FDT. Clear from one central point, you can do all these things without leaving the area. And of course, we have here also intrinsic safety areas or hazardous areas, yeah, where there is a limitation on calibration, locally calibration, yeah, because then again you need these kinds of papers and have to be careful with laptops and all these things because it is hazardous area. And all this remote calibration can be done via HART from the control room. This is a big story there because it's easy to make that from a control room, especially if you have such a big plant where devices can be everywhere and the distance can be wide. Then another plant, Krotecheluk, I don't know the name, it's very good, but it is a coal mine. And this coal mine is especially interesting because they say, okay, we don't want to have big network structures behind. We like the possibility of, let's say, making a point-to-point connection. Yeah, it's for us enough. We use a sensor, we use, let's say, a hard modem, and we use Pactware or another tool, in this case Pactware, and then we make the configuration local. Yeah, it is not, it is very easy, and that is the mainly point how they work with this tool. Yeah, so going to the devices and make the calibration and diagnostic in the field local. But what happens if you have difficult application? Yeah, you see here some sensor very difficult in a difficult location where you not really can connect to them in the field, yes, or somewhere here where it is really with a lot of dust and so on. In this difficult application, sometimes networks are interesting. And now I go again to another example, to SAPI. And this is a global manufacturer of producing fine paper and chemical cellulose. And this, in this plant, the option was more to go for network again. Yeah, have a central place and trying to configure. Mainly it was Profibus devices which they have there, but maybe in future also some hard devices. Yeah, and well, you see here the constellation. Pactware was used again here as calibration and as tool, as configuration tool, and going over the Profibus network, and are using again different DTMs from different from FDT members we have. And you see here also the way they have on the one side, they have here, let's say, a kind of segment coupler going down to the different field devices. The mainly job there is Profibus. If you have Profibus, of course, it is sometimes more comfortable as only hard, because then Profibus itself is a little bit faster. Yeah, with 90, well, we have here 31.25 kilobits per second. Hard is relatively slow with 1.2 kilobit per second. Yeah, but mostly it's enough. But here, of course, if you are using a real field bus structure, and maybe the future can look like that for them, so they have both options, but then you have, of course, a relatively fast connection to your device, yeah. And interesting in Profibus is also that and also Fieldbus Foundation, that the status information comes automatically with the measuring value, yeah. The measuring value comes to the DCS and it automatically gives you also in status. But at heart, you have to ask the device, hey, give me the status, I want to know what is your status at the moment. So there is, it's a little bit slower and you have to ask for that, yeah. And the bus systems normally gives you all this in details automatically. Therefore, it's sometimes interesting to use a complete field bus. And this is exactly what SAPI does. Yeah, they use Profibus. They have a Profibus master above. Yeah, Pactware is used as Profibus master, master class 2. The DCS system is master class 1. It's the real working DCS, and Pactware as separate master class 2 is making the configuration job and maybe also some kinds of diagnostic if necessary. Yeah. Okay, a further example which I want to show you is something close to us, Botswana. And here we have to say the question we had this morning, the story of the wireless. It's an area which relatively isolated, and then here the possibility of using modems inside or close to the location is very interesting, because the modem is connected to the sensor via an evaluation unit, and the modem itself has a SIM card inside, yeah, and the SIM card provides you a telephone number. So, and now it's relatively easy to connect via an FDT tool, whatever it is, which is located thousands of kilometers away, to connect by calling this telephone number. And then, due to a communication DTM in your project, you can have the access to this modem and automatically then also to the device itself. That means these are the typical plans where we avoid to go with service personnel so often to these plans. Yeah? We can really avoid it. If there is some issue or so, we can check very comfortably by using this FDT tool and make everything wireless over thousands of kilometers. By the way, we are doing that in our company in Germany also the same. We have contact from Germany to all over the world. There are different modems. If there is some issue somewhere, then we need to know what is the telephone number of this particular modem, and then we can call from Germany to this modem and connect to the devices. Yeah, so that we can help our local service by looking for some optimization of the device or whatever. Yeah? So this are possibilities which is also absolutely possible with FDT, no problem. Well, yeah, tank information is also available. So we have both. We have on the one side, we have configuration. On the other side, we have, it's more or less the same. We have also diagnostic possibilities to get out of the device. And we have also the possibilities to transferring this information, the measuring values, out of the system. That means both configuration, diagnostic, and of course also the measuring values. This is possible with this technology. Good. Well, resuming a little bit, we can say, okay, without FDT and Pactware, it is difficult and costly to plan maintenance. Yeah? So FDT, Pactware, or FDT, the whole concept, helps really in terms of optimizing all these maintenance costs. Yeah? You have here a big tool which helps you by all these configuration possibilities to have an interesting and good access to your devices. And other statement with FDT and Pactware, intelligent transmitters and positioners, everything becomes easier. Yeah, because you really have access to all the information of the device. You don't really have to go outside like this guy here. He goes outside, okay, but you can do it also from the control room. Yeah, so both is possible. Important is really it is absolutely usable for every bus system. You can use it from a lot of manufacturers. All is available. You can use it point to point, or you can use it also via your control room. So the access to the intelligence of the device is available.